Top 48 Electronics Interview Questions and Answers. If you're preparing for an electronics interview and feeling overwhelmed by formulas, circuits, and technical terms, relax, you're in the right place in this video. We'll break down the top 48 electronics interview questions and answers in a simple, practical, and confidence-boosting way. Whether you're a fresh graduate or an experienced engineer, these explanations will help you think clearly, answer professionally, and stand out in any electronics job interview. 1. Can you tell us about yourself? I am an electronics graduate with a strong foundation in circuit theory, semiconductor devices, and practical lab experience. I enjoy understanding how electronic systems work from component level to complete applications. During my studies, I worked on projects involving analog and digital circuits, troubleshooting hardware issues, and basic embedded systems. I am highly motivated to learn, adaptable to new technologies, and eager to contribute my technical skills while growing professionally in a challenging electronics role. 2. What is electronics engineering? Electronics engineering is a branch of engineering that focuses on designing, developing, testing, and maintaining electronic circuits and systems. It deals with components like resistors, capacitors, transistors, diodes, and integrated circuits. Electronics engineers work in areas such as communication systems, consumer electronics, embedded systems, automation, and power electronics. The field combines theoretical knowledge with practical application to solve real-world problems using electronic principles and modern technologies. 3. What is the difference between analog and digital electronics? Analog electronics deals with continuously varying signals, such as voltage or current levels that represent real-world quantities. Digital electronics works with discrete signals, usually represented by binary values 0 and 1. Analog circuits are sensitive to noise but provide smooth signal representation. Digital circuits are more robust, easier to store and process, and widely used in computers, microcontrollers, and communication systems. Both types are essential and often combined in modern electronic systems. 4. What are passive components? Passive components are electronic components that do not generate energy but instead store, dissipate, or control electrical energy. Common passive components include resistors, capacitors, and inductors. Resistors limit current flow, capacitors store electrical charge, and inductors store energy in a magnetic field. These components are fundamental in shaping signals, controlling voltage and current, filtering noise, and stabilizing electronic circuits. They form the basic building blocks of almost every electronic system. 5. What are active components? Active components are electronic devices that require an external power source to operate and can amplify or control electrical signals. Examples include transistors, diodes, integrated circuits, and operational amplifiers. Unlike passive components, active components can increase signal strength or perform switching and signal processing functions. They are essential for amplification, oscillation, signal modulation, and logic operations. Active components enable complex functionalities in electronic systems, including computation, communication, and control applications. 6. What is Ohm's law? Ohm's law defines the relationship between voltage, current, and resistance in an electrical circuit. It states that current is directly proportional to voltage and inversely proportional to resistance. Mathematically, it is expressed as V equals I multiplied by R. This law is fundamental for analyzing and designing electrical circuits. Engineers use Ohm's law to calculate unknown values, verify circuit behavior, and ensure components operate within safe electrical limits. 7. What is Kirchhoff's law? Kirchhoff's laws consist of two principles used for circuit analysis. Kirchhoff's current law states that the total current entering a node equals the total current leaving it. Kirchhoff's voltage law states that the sum of voltages around any closed loop in a circuit is 0. These laws help analyze complex circuits where simple methods are insufficient. They are essential tools for understanding current flow, voltage distribution, and overall circuit behavior. 8. What is a semiconductor? A semiconductor is a material with electrical conductivity between that of a conductor and an insulator. Common semiconductor materials include silicon and germanium. Their conductivity can be controlled by adding impurities through a process called doping. Semiconductors form the foundation of modern electronics, enabling the creation of diodes, transistors, and integrated circuits. Their ability to control current flow makes them essential for amplification, switching, and signal processing applications. 9. What is doping in semiconductors? Doping is the process of adding small amounts of impurities to a pure semiconductor material to modify its electrical properties. When trivalent impurities are added, p-type semiconductors are formed. When pentavalent impurities are added, n-type semiconductors are created. Doping increases the number of charge carriers, improving conductivity. This controlled modification allows engineers to design semiconductor devices with specific characteristics required for diodes, transistors, and integrated circuits. 10. What is a p-n junction? A p-n junction is formed when p-type and n-type semiconductor materials are joined together. At the junction, electrons and holes recombine, creating a depletion region that acts as a barrier to current flow. When forward biased, the barrier reduces, allowing current to flow. When reverse biased, the barrier increases, preventing current flow. P-n junctions are the fundamental building blocks of diodes, transistors, and many semiconductor devices. 11. What is a diode? A diode is a two-terminal semiconductor device that allows current to flow in only one direction. It consists of a p-n junction and operates based on forward and reverse biasing. Diodes are commonly used for rectification, converting AC to DC. They also serve roles in voltage regulation, signal clipping, and protection circuits. Special types of diodes include Zener diodes, LEDs, and photodiodes, each designed for specific electronic applications. 12. What is a Zener diode? A Zener diode is a special type of diode designed to operate in reverse breakdown mode without damage. It maintains a constant voltage across its terminals when the applied voltage exceeds its Zener voltage rating. This property makes it ideal for voltage regulation and reference applications. Zener diodes are commonly used in power supplies to protect circuits from overvoltage conditions and to provide stable voltage levels for sensitive electronic components. 13. What is a transistor? A transistor is a three-terminal semiconductor device used for amplification and switching applications. It controls the flow of current between two terminals using a small input signal at the third terminal. Transistors are the backbone of modern electronics and are used in amplifiers, digital logic circuits, and microprocessors. Common types include bipolar junction transistors and field effect transistors, each with unique operating principles and application areas. 14. What is the difference between BJT and FET? A BJT is a current-controlled device that uses both electrons and holes for conduction, while a FET is a voltage-controlled device that uses only majority carriers. BJTs offer high gain but consume more power. FETs have high input impedance and lower power consumption. Because of this, FETs are widely used in integrated circuits and digital systems, while BJTs are often preferred in analog amplification applications. 15. What is an amplifier? An amplifier is an electronic circuit that increases the amplitude of an input signal without changing its original shape. It uses active components such as transistors or operational amplifiers. Amplifiers are classified based on configuration, frequency range, and application. They are used in audio systems, communication devices, instrumentation, and signal processing. Proper amplifier design ensures sufficient gain, stability, efficiency, and minimal distortion for reliable electronic system performance. 16. What is gain? Gain is the ratio of output signal amplitude to input signal amplitude in an electronic circuit. It indicates how much an amplifier increases the strength of a signal. Gain can be expressed in terms of voltage, current, or power and is often measured in decibels. High gain is essential for weak signal amplification, but excessive gain can introduce noise and distortion. Engineers design circuits to achieve optimal gain for specific applications. 17. What is feedback in amplifiers? Feedback is the process of feeding a portion of the output signal back to the input of an amplifier. It can be positive or negative. Negative feedback improves stability, reduces distortion, and increases bandwidth. Positive feedback increases gain and can lead to oscillations if uncontrolled. Feedback is widely used in amplifier design to enhance performance, control gain, and maintain consistent operation under varying conditions and component tolerances. 18. What is an operational amplifier? An operational amplifier, or op-amp, is a high-gain differential amplifier with very high input impedance and low output impedance. It amplifies the difference between two input voltages. Op-amps are versatile and used in applications such as amplification, filtering, integration, differentiation, and signal conditioning. Common op-amp configurations include inverting, non-inverting, and voltage follower. Their flexibility makes them essential components in analog electronic design. 19. What is bandwidth? Bandwidth refers to the range of frequencies over which an electronic system or amplifier operates effectively. It is defined as the difference between the upper and lower cutoff frequencies. Within this range, the system maintains acceptable gain and performance. Bandwidth is a critical parameter in communication systems, audio electronics, and signal processing. Wider bandwidth allows transmission of more information but may increase noise and design complexity. 20. What is noise in electronics? Noise refers to unwanted electrical signals that interfere with the desired signal in an electronic system. It can originate from thermal effects, electromagnetic interference, or component imperfections. Noise degrades signal quality and limits system performance. Common types include thermal noise, shot noise, and flicker noise. Engineers reduce noise through proper circuit design, shielding, filtering, and selecting high-quality components to ensure reliable and accurate signal processing. 21. What is digital electronics? Digital electronics deals with circuits that operate using discrete voltage levels, typically representing binary values 0 and 1. These circuits are used in computers, microcontrollers, digital communication systems, and embedded devices. Digital systems offer high reliability, noise immunity, and ease of data storage and processing. 22. What are logic gates? Logic gates are basic digital circuits that perform logical operations on binary inputs to produce a binary output. Common logic gates include AND, OR, NOT, NAND, NOR, XOR, and XNOR. They are the fundamental building blocks of digital systems. By combining logic gates, complex digital circuits such as adders, multiplexers, and processors can be designed. Logic gates enable decision-making and data processing in digital electronics. 23. What is a flip-flop? A flip-flop is a bistable digital circuit that stores one bit of information. It has two stable states representing binary 0 and 1. Flip-flops are used in memory elements, registers, counters, and timing circuits. Common types include SR, JK, D, and T flip-flops. They operate based on clock signals and are essential for sequential logic circuits where data storage and synchronization are required. 24. What is a microcontroller? A microcontroller is a compact integrated circuit that contains a processor, memory, and input-output peripherals on a single chip. It is designed to control specific tasks in embedded systems. Microcontrollers are widely used in consumer electronics, automation, automotive systems, and IoT devices. They offer cost-effective, low-power solutions for controlling hardware, processing data, and interacting with sensors and actuators in real-time applications. 25. What is the difference between microcontroller and microprocessor? A microprocessor contains only the central processing unit and requires external memory and peripherals. A microcontroller integrates the CPU, memory, and peripherals on a single chip. Microcontrollers are used in embedded systems for specific control tasks, while microprocessors are used in general-purpose computing systems. Microcontrollers consume less power and are cost-effective, making them ideal for dedicated applications, whereas microprocessors offer higher performance and flexibility. 26. What is communication system? A communication system is designed to transmit information from a sender to a receiver over a communication channel. It includes components such as a transmitter, channel, and receiver. Communication systems can be analog or digital and are used in radio, television, mobile networks, and internet technologies. Key parameters include bandwidth, noise, signal-to-noise ratio, and modulation techniques. Effective communication system design ensures reliable data transmission with minimal distortion. 27. What is modulation? Modulation is the process of varying a carrier signal's properties, such as amplitude, frequency, or phase, according to the information signal. It allows efficient transmission of signals over long distances. Common modulation techniques include AM, FM, and PM. Digital modulation schemes include ASK, FSK, and PSK. Modulation improves signal strength, reduces interference, and enables multiple signals to share the same communication channel efficiently. 28. What is demodulation? It is a critical function in communication systems. Proper demodulation ensures accurate recovery of transmitted data. Different demodulation techniques are used depending on the modulation scheme. Effective demodulation minimizes distortion and noise, ensuring clear communication in radio, television, and digital communication systems. 29. What is signal-to-noise ratio? Signal-to-noise ratio, or SNR, is a measure of signal strength relative to background noise. It is usually expressed in decibels. A higher SNR indicates better signal quality and clearer communication. Low SNR results in distortion and data loss. SNR is a crucial parameter in communication systems, audio electronics, and instrumentation. Engineers aim to maximize SNR through proper design, filtering, and noise reduction techniques. 30. What is bandwidth in communication? Bandwidth in communication refers to the range of frequencies that a communication channel can transmit effectively. It determines the data rate and capacity of the system. Higher bandwidth allows faster data transmission but requires more resources. Bandwidth is a limited and valuable resource in wireless communication. Efficient bandwidth utilization is essential for modern communication systems to support high-speed data, video streaming, and multiple users simultaneously. 31. What is power electronics? Power electronics deals with the conversion, control, and conditioning of electrical power using electronic devices. It involves circuits that handle high voltages and currents. Applications include power supplies, motor drives, renewable energy systems, and electric vehicles. Power electronics improves energy efficiency and enables precise control of power flow. Devices such as thyristors, MOSFETs, and IGBTs are commonly used in power electronic systems. 32. What is a rectifier? A rectifier is an electronic circuit that converts alternating current into direct current. It uses diodes to allow current flow in one direction only. Rectifiers are essential components in power supplies. Common types include half-wave, full-wave, and bridge rectifiers. Rectification is often followed by filtering and regulation to produce a smooth and stable DC output suitable for powering electronic devices and circuits. 33. What is a power supply? A power supply is an electronic device that provides electrical energy to an electronic system. It converts input power from a source into the required voltage, current, and form. Power supplies can be linear or switch mode. They ensure stable and reliable operation of electronic circuits. Proper power supply design protects components from voltage fluctuations, reduces noise, and improves overall system performance and longevity. 34. What is embedded system? An embedded system is a dedicated computer system designed to perform a specific function within a larger system. It includes hardware and software optimized for real-time operation. Embedded systems are used in appliances, medical devices, automotive systems, and industrial automation. They prioritize reliability, efficiency, and low power consumption. Microcontrollers and real-time operating systems are commonly used to implement embedded system functionality. 35. What is PCB? A printed circuit board, or PCB, is a board used to mechanically support and electrically connect electronic components. It consists of conductive tracks etched onto an insulating substrate. PCBs improve circuit reliability, reduce wiring complexity, and allow compact designs. They are used in almost all electronic devices. PCB design involves layout planning, component placement, routing, and ensuring electrical and thermal performance requirements are met. 36. What is soldering? Soldering is the process of joining electronic components to a PCB using a molten metal alloy called solder. It creates a reliable electrical and mechanical connection. Proper soldering ensures good conductivity and long-term reliability. Poor soldering can lead to faults such as cold joints or short circuits. Soldering skills are essential for electronics technicians and engineers involved in prototyping, assembly, and hardware troubleshooting. 37. What is multimeter? A multimeter is a versatile measuring instrument used to measure electrical parameters such as voltage, current, and resistance. It can be analog or digital. Multimeters are essential tools for troubleshooting and testing electronic circuits. They help verify component values, detect faults, and ensure circuits operate correctly. Advanced multimeters may also measure capacitance, frequency, and continuity, making them indispensable in electronics work. 38. What is oscilloscope? An oscilloscope is an electronic test instrument used to visualize electrical signals as waveforms. It displays voltage versus time, allowing engineers to analyze signal amplitude, frequency, and shape. Oscilloscopes are essential for debugging analog and digital circuits. They help identify noise, distortion, and timing issues. Modern digital oscilloscopes offer advanced features such as signal storage, measurement automation, and waveform analysis. 39. What is troubleshooting in electronics? Troubleshooting is the systematic process of identifying and fixing faults in electronic circuits or systems. It involves analyzing symptoms, testing components, and isolating faulty sections. Effective troubleshooting requires theoretical knowledge, practical experience, and logical thinking. Tools such as multimeters and oscilloscopes are commonly used. Good troubleshooting skills reduce downtime, improve system reliability, and are highly valued in electronics engineering roles. 40. What is preventive maintenance? Preventive maintenance involves regular inspection, testing, and servicing of electronic equipment to prevent failures. It helps identify potential issues before they cause system breakdowns. Preventive maintenance improves equipment lifespan, reliability, and SAFE-TI. Activities include cleaning, calibration, component replacement, and performance checks. In industrial and critical systems, preventive maintenance reduces downtime and repair costs, ensuring continuous and efficient operation of electronic equipment. 41. What is ESD? Electrostatic discharge, or ESD, is the sudden flow of electricity between two electrically charged objects. It can damage sensitive electronic components. ESD occurs due to static electricity buildup and discharge. Proper ESD protection measures include grounding, using anti-static wrist straps, mats, and packaging. Understanding and controlling ESD is essential in electronics manufacturing, handling, and repair to prevent component failure and reliability issues. 42. What is EMI? Electromagnetic interference, or EMI, is unwanted disturbance caused by electromagnetic radiation affecting electronic devices. EMI can degrade performance or cause malfunction. Sources include power lines, radio signals, and electronic circuits. EMI reduction techniques include shielding, grounding, filtering, and proper circuit layout. Managing EMI is critical in high-frequency and sensitive applications such as communication systems, medical equipment, and precision instrumentation. 43. What is grounding? It provides a safe path for fault currents and stabilizes voltage levels. Grounding improves SAFI-TI, reduces noise, and protects equipment from electrical surges. Proper grounding is essential in power systems, electronic circuits, and communication equipment. It ensures reliable operation and compliance with SAFI-TI standards. 44. What is filtering? Filtering is the process of removing unwanted frequency components from a signal. Filters are used to reduce noise, smooth signals, and separate frequency bands. Common filter types include low-pass, high-pass, bandpass, and bandstop filters. Filters can be passive or active. They play a crucial role in communication systems, audio electronics, and signal processing by improving signal quality and system performance. 45. What is calibration? Calibration is the process of comparing and adjusting the accuracy of measurement instruments against a known standard. It ensures that instruments provide accurate and reliable readings. Regular calibration is essential in testing, manufacturing, and quality control. Calibration helps maintain consistency, reduce errors, and comply with industry standards. In electronics, calibrated instruments ensure correct measurements, leading to better design, troubleshooting, and system reliability. 46. What is automation in electronics? Automation in electronics involves using control systems, sensors, and electronic devices to operate processes with minimal human intervention. It improves efficiency, accuracy, and SAFI-TI in industrial and commercial applications. Automation systems use programmable controllers, sensors, actuators, and communication networks. Electronics engineers design and maintain these systems to optimize performance. Automation plays a vital role in manufacturing, robotics, and smart infrastructure. 47. What are your strengths as an electronics engineer? My strengths include strong analytical skills, a solid understanding of electronic fundamentals, and hands-on experience with circuits and instruments. I am detail-oriented, patient during troubleshooting, and comfortable working with both hardware and documentation. I adapt quickly to new technologies and enjoy learning continuously. My problem-solving mindset allows me to approach challenges logically, making me effective in diagnosing issues and delivering reliable electronic solutions. 48. Why should we hire you? You should hire me because I bring a strong foundation in electronics, a practical understanding of real-world systems, and a genuine passion for learning. I am disciplined, reliable, and eager to contribute to team goals. I can quickly adapt to your work environment and continuously improve my skills. My commitment to quality, SAFI-TI, and problem-solving ensures I add value while growing with your organization. That wraps up our top 48 electronics interview questions and answers. If you found this video helpful, hit the like button, share it with your friends, and subscribe for more interview-focused tech content. These questions aren't just about memorization, they're about understanding, confidence, and clarity. Keep practicing, stay curious, and walk into your next electronics interview fully prepared. You've got this.